All right, I think we are live. Hi, everyone. Thank you for joining us. Today. My name is Sasha Zelanovic, and I manage AI developer marketing here at Red Hat. I've said this many times before, but one of my favorite things that I do at Red Hat is these office hours. So thank you very much for coming, for supporting this program. We are on our 31st session, which is very hard to believe. They started about a year ago, but it's been awesome also to see the program grow and a lot of interest. So please keep it coming. So today we have we'll share our regular, Michael Goin will share a regular bi-weekly vLLM update. And then we have Brian and Kyle here from Red Hat's model optimization team sharing what's new in the LLM compressor and giving you a little more insight into what LLM compressor does and what's new in the most recent release. So we're really excited about that one. So Michael, can you please go on the next slide? So just a few housekeeping slides. We are recording this session. The recording will be posted on YouTube almost momentarily after the event. So feel free to find it there. We'll also link the slides. The slides are already linked actually in the chat right here. So please feel free to follow along. And if you want to share the recording with your colleagues and friends, please do. We are also live on YouTube and live on X. So if you have any connectivity issues with Google Meet, that's always a place to look. You can also ask questions on YouTube and on X. We'll make sure to paste them over here and get your answers. Just a quick call out on Meetups. We had some amazing Meetups across Asia, specifically over the last week. Michael, I believe you have a few slides on those to share some of the feedback there, which is amazing. We have 2 more planned for in North America coming up in September. Boston is happening on 9/18. So if you're local to Boston or can travel to Boston, we would love to see you there. The registration page is linked right here where it says Boston. And then we also have Toronto pretty much in the market already, all planned. We have the agenda solidified. We're just creating a registration page as we speak. So in the next 24 hours, if you pay attention to our X account, we'll probably get something out there. So we would love to see you. It's a 3-hour event in the afternoon, in the evening, usually with light refreshments, whether it's pizza or sandwiches, depending on the meetup. But it's a great place to learn more about vLLM, go a little bit deeper than we actually even do in office hours, and just meet the community, interact, give feedback, ask questions. So before I pass it over to Michael, we'll keep up with our tradition here and ask everyone where you're dialing in from. So if you want to pull up your chat and tell us where you're dialing in from, flags on the right-hand side of this slide from countries that joined before. Jordan was the most recent one added, so that was awesome. It would be great. Oh, Michael in Munich today. Fortunately, I guess we do have the German flag already. I wish I could add it for you twice. Hi, Aldo from California, India. Hello, Max from Rio, San Diego, Ireland. I think we have the Irish flag, right? Yes, I always mix that with the Italian. I know I shouldn't say that. But yes, we do have the Irish flag. Hey, Kyle, Boston, Austin, Texas, China. Awesome. We've had China before, of course. Atlanta, Georgia, Arlington. All right, Michael, if you can please go to the next slide. We keep releasing we keep releasing a lot of blogs. Our team is super busy pushing blogs and content out that's developer friendly. We would love for you to check out some of them. Again, slides are linked in the chat notes, so feel free to click into some of these. But today's topics have been actually already blogged out, so you can actually, if you like reading or solidify your knowledge through reading after the office hours, feel free to check out the first blog on the list. LinkedIn just pushed a great blog about how they use vLLM, and they share some of their specific use cases and the results they're seeing. So totally worth checking the 2 blogs out from LinkedIn. One of our engineers at Red Hat wrote a great blog about optimizing Gen AI models with quantization using LLM Compressor. We've optimized a lot of the models already, and we pushed these to our Hugging Face model repo, Red Hat AI Hugging Face, if you want to Google it. But if the model is not there, this blog really digs deep into how you can actually use LLM Compressor to optimize your own model that might not be something that we've already optimized. We've also shared the torch.compile and how it works in vLLM. That's been posted on the vLLM blog. That's also another recap from previous office hours. So if you couldn't catch those, check them out. And we also have a pretty good blog on getting started with LLMD for distributed inference, and say deep dive into LLMD, but also share some use cases and examples of how you can actually get started. Michael, do you have anything to add here before I pass to you?
Yeah, I mean, it being amazing that all of these blogs are over the past 2 weeks. Obviously, lots of model releases that vLLM was a part of. So, recommend checking out the GLM 4.5 and yeah, like some of the other blogs here. Check out Amazon, how they use vLLM, how LMD builds on top of vLLM. Yeah, get your reading in. Yeah, well, I'll take it from you, Sasha. Good to see everyone again. Michael here. Hopefully you remember me. Today we're going to go over what's happened in the past 2 weeks in the vLLM community. Obviously, all those great blogs, of course. But we'll also cover, last week the latest version of DeepSeek released, which we have some support and guidance for. Also, some interesting community projects came out. There was this really cool vLLM CLI, which I'll show briefly. And of course, like Sasha mentioned, we've had 3 meetups at least in the past 2 weeks, which has been really great, with a lot more to come. And of course, as always, we'll cover the latest vLLM release that came out. Yeah, the special topic today is going to be an update on LLM Compressor. What's the latest release there? Followed by some distributed inference scheduling updates from LMD and vLLM folks at September 11th. And then after that, a deep dive into Mamba and model support in vLLM as we get more and more of those model architectures coming out. So if you're not familiar with vLLM, it's the de facto standard in open source model serving. Both in terms of offline inference and of course online model serving. So people use vLLM to make their own ChatGPT API essentially with open source models. As you can see, it's had very steady contribution and star growth. Over 1,000 contributors. I think now we have over 1,400 contributors now. Unique people that have landed code in the project, which is pretty crazy. For only being about 2.5 years old. Of course, it's easy to use, but it's also very fast and efficient with the hardware that you're able to give it. And so the reason why it's become so popular is, of course, because it's fast and brought some advances with it in terms of inference acceleration research. But it's also kept up in terms of implementing the 100+ different model architectures that live inside of it. And being an active place for researchers in ML systems to fork, implement their own ideas, publish those both in research and in the community, and then get those changes pulled back into the project, which has meant vLLM as up with a lot of the research as it comes out and gets adopted by model labs and industry. And of course, it gets good performance on NVIDIA GPUs by default. But through the software abstraction that it provides in combination with PyTorch, we're able to support many different types of hardware backends and get good performance and the same user interface in terms of vLLM Serve works on NVIDIA GPUs, AMD GPUs, Google TPUs, and the various other accelerators, which many more are added over the months as we now have a hardware plugin backend system as well. And of course, there's the ease of use and the performance that it gets, but it's not just providing that for text-only large language models. It also has very robust support for multimodal models, so dozens of different multimodal architectures, hybrid attention, so modern methods like linear attention, chunked attention, and like state space models with Mamba. And it also supports encoder-only models, so efficiently inferencing embedding models, and of course, offering help with reward modeling when doing reinforcement learning tasks, where the training that happens in RLHF is now split kind of 50-50 between training and inference. So vLLM becomes an even more important part of modern training pipelines. Of course, lots of quantization support, which the LLM Compressor team is going to talk about some of the new things that vLLM supports that come from LLM Compressor. And doing that with many different custom kernels that we develop with several different domain-specific languages like Triton, Cutlass, and automatic code generators like Torch Compile. And then, of course, aside from fast matrix multiplications and operations, you have inference system level optimizations like chunked prefill, prefix caching, multi-layer batching that allow you to serve workloads and do your forward passes through the model in a more efficient, workload-aware manner. And then, of course, the different, application level features that people moving from a closed source API to hosting their own model API need in order to build their applications, like tool calling, unstructured outputs. And finally, stretching and serving your model at scale beyond a single device, spreading to multiple devices within a node using tensor parallelism, and spreading to multi-node cluster scale inference with expert parallelism and data parallelism as we serve large MOEs like DeepSeek and Llama 4. So a bit of the reason why we at Red Hat work a lot on vLLM is we work a lot on vLLM and we support a lot of enterprises that use vLLM in production. And we do that because we work on all different parts of it, particularly a lot of the performance, quantization support, using the latest libraries like Cutlass, and making sure performance is very at a very high level on the different hardware backends, but also production level features like observability and metrics, and generally reducing system overhead. So we spend more time on the GPU and less time waiting for the CPU. Yeah, we're really happy to be a part of the project and help out with the many other companies that collaborate too. So yeah, some of the things I wanted to cover since the last time we met is the DeepSeek 3.1 launch. This is a pretty similar architecture. Not much has changed. There is a slight difference with the input, or the quantization now has a different type of scale. It has a unsigned 8-bit integer scale rather than a floating point 32 scale. So we have to change the calculation there to be a little bit more accurate to how it's trained. But there's a lot of extra capability in terms of the hybrid thinking, non-thinking within a single model, and just generally increased capabilities of the model and better kernels we have this time around to run it even faster. So highly recommend checking out the vLLM recipes docs if you haven't checked it out before. We're growing that with the community. Feel free to contribute yourself, but it's essentially the source of truth for what is it, what are the recommended commands essentially for deploying a given model on a given amount of hardware. Yeah, that's the recipe for DeepSeek v3.1. And then another thing I wanted to call out was a community project that actually came by last week called vLLM CLI. It's not anything big or anything crazy, but it's just a really cool text interface for keeping track of all the vLLM processes you have on your server. So it keeps track of like multiple vLLM servers running on different GPUs. How are they being loaded? Managing the different models you have available on disk, and also kind of similar to the recipes that we have in documentation, but like profiles and configs for deploying a model optimally on some bundle of hardware. All sort of useful tools in terms of managing your use of vLLM. So it's a really early project, but we thought it was pretty cool. So hopefully you find it cool too. And then, yeah, just wanted to give a quick shout out for the great meetups that happened over the past 2 weeks. We had our first meetup in Korea, co-hosted with Rebellions, a hardware manufacturer there that's joined the vLLM community and contributing their hardware plugin, which is really cool. And then we went back to China and had a very successful meetup in Shanghai. That was hosted by MetaX, which is another hardware provider that's working on a plugin backend for vLLM. Hopefully you see the theme. And a lot of exciting updates from them. and also like from the Ernie team and the Mooncake team on their work on vLLM. And then just yesterday, we had a meetup co-sponsored by OpenAI and Olama on the GPT OSS model at the YC offices in San Francisco. And that was, yeah, a great time too, as people are definitely using GPT OSS a lot. So it's definitely been interesting to see the interest behind that. So without further ado, I'll get into what's new in this release. It was a pretty massive release. We had over 700 commits within 2 weeks, which is pretty intense, but we're happy to get a lot of stuff in, especially getting over 100 new contributors within one release is pretty great. Yeah, we're really excited to see new people coming and joining the project all the time. Obviously, we supported OSS on day 0, but that was done sort of on a branch. So this is the first release that we've released with GPT OSS supported on main, running on running with like MXFP4 and all the optimal ways you want to run it on NVIDIA Hopper Blackwell GPUs and also AMD GPUs. There's also Cohere's latest vision model, Command A Vision, which is formidable as well, and many other various models here in the list. We also, in terms of expanding model support to V1, we finally landed encoder model support. So you no longer need to be on V0 in order to support embedding models in your pipelines, and we're looking to see more performance improvements as a result of bringing that to V1. And another really critical thing which people have questioned, I think, for a while with vLLM V1 is the piecewise CUDA graphs. Basically, in V1, sort of by default, we use CUDA graphs everywhere except for the attention layer. And now we're bringing in the ability to mix and match these things. So now we officially have full CUDA graph support, and we're bringing that into various different attention backends as they're able to implement it. And we started with Flash Attention 2 and 3, Flash Infer, Cutlass MLA, and we already have a few more on main that didn't make this release. So yeah, this is going to give a really big improvement for really low latency, low batch size cases, particularly for very small models. So yeah, we're looking forward to vLLM V1 serving more users in the way they like to be served. Some other things on attention, Flex Attention continues to be more and more flexible. We think probably Flex Attention is going to be able to run every single type of model attention soon enough, except for maybe the hybrid attentions. And it expands to bidirectional encoder-only attention here. And then in terms of deploying GPT OSS efficiently, the Flash Attention 3 attention sync support was critical for that, and really great. Another thing I want to point out is the model loader plugin system. This is yet another plugin system, but it's pretty useful for particularly production deployments where people want to optimize how the model is loading from disk or from network into their device memory. And so now enabling that to not require in-tree changes and just allow plugins is a nice flexibility. Next, there's a lot of hardware performance. We've been pushing a lot, particularly on NVIDIA and AMD GPUs. What I'll really highlight is a ton of work with NVIDIA on increasing NVIDIA Blackwell support, so making sure B200 and GB200 are well supported. We have lots of kernels coming in from Flash Infer that are actually kernels coming in from Tensor LLM for greatly improving the performance of attention and MOE layers. So yeah, expect to see some pretty impressive large-scale MOE deployments on Blackwell that yeah, we hope to talk about soon. And then, as I mentioned, a good number of improvements on AMD ROC-N backend, continuing to push performance, especially for multimodal models and small overheads. Generally improving improving low latency as well. Another really notable thing, particularly if you use guided decoding, structured outputs at a really high throughput level, we found some pretty serious bottlenecks that can build up there. And so we're working on re-architecting how guided attention work or guided decoding works in vLLM. And this is already one type of parallelism that should greatly improve that. But we hope to make a lot of improvements over the coming weeks with the continued development of async scheduling in vLLM v1. And then one thing I'll point out that's really cool for those running GPT OSS on not the latest GPUs is we added MXFP4 support to the Marlin kernel. So if you're running on Ampere, so A100s, 3090s, and above, you can run the model the exact same way with weight-only MXFP4 quantization. Maybe not the state-of-the-art performance, but you can run the model in the exact same precision and get the same results you would on the leading-edge hardware that it was built for. And then quite a few more updates in terms of updating the API. Obviously, we added the OpenAI Responses API as part of the GPT OSS support. And as I mentioned, vLLM is being used more and more in reinforcement learning workflows. So we've finally added for the offline LLM interface, reward interface that's we're building in progress, hand in hand with the reinforcement learning libraries like vRL and verifiers. And various other improvements here. We're continuing the V0 deprecation. We think V0 should essentially be removed as of 0.11. So maybe a release or two left in there, but we're slowly removing more and more things that we've deprecated a few releases in the past. If you want to help deleting some code, we would love some help. That's all I have today. So I'm going to hand it over to Brian and Kyle to cover what's new with LLM Compressor.
Thank you, Michael. I can present here. Okay, can you all see the screen?
Yeah, looks good, Brian.
Perfect. Okay, thank you. Today Kyle and I would like to present the latest updates to LLM Compressor. We have v0.7. So I've been on the team since January. I'm based in Chicago. I don't know, Kyle, if there's anything you want to do, introduce yourself at all.
Yeah, sure. Kyle, Brian and I are both on the model optimization team. I'm based in Boston and Brian's based in Chicago. Super excited to give an update on our latest release of LLM Compressor, and then also updates within the model optimization ecosystem around vLLM.
Perfect. Okay, yeah, we're about a team of 6 and soon to be 7 in Red Hat. So so today we just want to share what we've been working on really for most of the quarter related to transforms, and then also some additional work that we've done for non-uniform quantization and further NVFP4 support. And then some other goodies like block quantization. I think Michael just mentioned that as well. So transforms are kind of a new avenue in the compression research game, come in a few different flavors. We want to talk about a couple. QUIP, the IP there stands for incoherence processing. And spin quant is the idea of spin. You rotate something, you transform it, and then you quantize. So spin quant comes in a couple. We'll go through some more of those. It actually extends some of this work on Carrot, Quarat, as some people call it. So we call it spin quant just for ease of use, but just know for now it's what we have so far is equivalent to Carrot, and we're in what's ahead. We'll be adding the remaining parts of spin quant. They're all pretty close. Require some additional work in vLLM. But that will be landing that in a release soon. Helen on our team created this image just to kind of show you this is the general flow we want with transforms. Before quantization, we can apply a transform. The idea is that by doing so, we can reduce the quantization loss and then move to the eval to see how things improve. And this also works with other modifiers in LLM Compressor in between as well, like GPTQ or AWQ. Yeah, in terms of what's ahead, we still need to do a lot of comprehensive benchmarking when this is all in vLLM. It should allow us to go to much larger models and do this a lot more quickly. We're pretty limited, especially with Quip, in like some of the benchmarks that we can run, but those are the things to come. So I do want to cover like what is the big idea behind transforms and kind of go through a little bit of the math. I know there's people probably with very different backgrounds here, so we want to make this as digestible as possible, but kind of go through that and then explain what is the difference between some of these different algorithms like Quip, Caret, and SpinQuant, and then we'll talk about how it can be used and moving on. But the basic idea is computational invariance. Like if you want to explain that to a 5-year-old, if you want to add 2 plus 5, you can add 2 plus 1 minus 1 plus 5, and you end up with the same result at the end. So we want to use something like that to our advantage, so that when it gets to the point of quantizing activations or weights, that we can reduce the quantization loss without changing the model output at the end. So this comes from the term computational invariance. I first saw it in Slice GPT. Thought it was a really handy way to think about this. We can apply a transformation to each weight matrix without changing the model output. So Quip and Caret, one of those referenced Slice GPT to say where Slice GPT was doing structured pruning, we're going to use it to reduce outliers in our activations. And we want to use a specific transform called the Hadamard transform, which is a rotation in that you can apply it back, and you end up with the same thing. That's what's shown here. We have Hadamard multiplied by the transpose of the Hadamard, and we end up with the identity matrix at the end times some scalar. This is kind of the shape on the right side here. So you can see like there's if you think of the white blocks as being +1s and the red blocks as being -1s, that we just have a structured ordering of +1s and -1s in our matrix, so that when we apply it, as we're showing in this, or as Caret shows in this slide down below, if our outliers in our activations look like the left side, you can see that we clearly have some outliers here. That if after we apply the Hadamard on it, we end up with a much smoother landscape, so that when we quantize, we end up with less quantization error from doing so. So that might, that's one thing. It might make sense to go through this in more of like, we have a little animation here that Kyle created. I think is really handy to see this. So if we have our weight matrix is the green block, and our input activations are the X block. You see this a lot in your model. You have a linear transformation. We can do something computationally invariant, that this is equivalent to adding these matrices in here. We have our U matrices and our V matrices. Imagine that these are Hadamards, so that if we multiply it by its transpose, we end up with the identity matrix. That this amounts to the exact same operation. We can instead of when we actually apply this, if we instead apply, move our parentheses associatively into or commutatively into this. No, so yeah, that we can then apply U to our weight as well as the transpose, and if the idea being, if we quantize that instead, that is going to be there's going to be less loss in our quantization from that. So by merging those in, by fusing those in, we can end up with a final result like this. And this is really the whole idea behind Quip, that for any linear matrix that we want to target, that we can apply either U or V or both, and end up with a situation like this. And then, because these are Hadamard matrices, it doesn't require a full dense matrix multiplication, so that these can be done somewhat quickly. So there's two ideas here with the rotations. We have a merge rotation. So these are really easy. It's just a matter of updating the weights. And then we don't have to really worry about anything beyond that. We just update the weights and then everything else can run. However, with these, at least for Quip, these are online rotations. These require updating something in our computational graph to allow for this, so that when the activations come in, we apply the Hadamard rotation to it, and then we apply the quantized weight matrix multiplication onto it. So merge rotations, really easy. Online rotations require either adding like a hook in Torch to allow them, or require updating in vLLM to allow for that. Okay, so that was Quip, and this is really SpinQuant and Carrot, and there's a lot on this page. I've looked at this image a lot over the course of this work. I think this really nicely sums up the kind of thing that we can do in SpinQuant. So instead of tackling the application layer by layer and then being done with it, the idea here with SpinQuant and Carrot is that we can take a given rotation, like R1, you can imagine this being a Hadamard, that we apply this very specifically throughout our model architecture, so that wherever we end up with something that is some kind of nonlinear operation, like multi-head self-attention, by the time it reaches that, it's back in the untransformed space. So you can imagine the output coming from the embedding is gray. So we're in the original space. We apply the rotation, and so this line becomes purple. So it is now in the transform space. We can apply the inverse so that we go back to the untransformed space, the original space, and then all of our operations will operate just as usual in the computationally invariant way. And then by the time we get to the end, we can rotate back into the transform space. So we have this really nice shape to it. And so this is just expanded out here. So in our multi-head self-attention, to show okay, we want to apply R1 inverse to our query key and value weight matrices, and at the end onto our O matrix, on the output of our O matrix. And conversely, in the MLP, we apply the inverse on the up and gate layers and on down on the output of the down layer. So R1 and R2 are what you would see in Carrot. What SpinQuant has added is this idea of these online rotations. Again, this is the part that's a little bit more tricky, requires adding through a webhook or through a custom code in vLLM to allow for that. But that the R1 and R2 can be applied and just merged in, and you have the exact same, your model can use the exact same model def and transformers or vLLM and work just the same. So these are what we have in v0.7. And then these are the things that we're targeting for the next release. Kyle's done a tremendous amount of work getting this working with vLLM. So it's there's a lot here, there's a lot of moving pieces, but we're really excited about this direction and hoping to have this landed soon, so that we can try it out in a much more comprehensive, large scale picture. Okay, so before I switch off to Kyle, are there any questions? Kind of a lot, I know, with some of this, but if people have any questions about kind of the background or the big idea for transforms before I pass off to Kyle. If not, let me go to Kyle. You want to take over?
Yeah, sure. Thanks, Brian. So as Brian kind of mentioned, these transforms that we can apply to a model really allow us to apply quantization in a way that is able to get much better recovery, especially at lower bit, lower bit quantizations like FP4 and 4, right? So the question now is now that we kind of understand the concept of applying transforms to a model, how do we actually do that within the LLM compressor tool? So right here is a quick demo of how you would do this. What's really neat about this is we're kind of leveraging the existing framework of LLM compressor, where we have these concepts of modifiers. And and we apply these modifiers to a model in sequence. So the key part here is basically your standard recipe that you would use to quantize a model is altered slightly just by adding a quip modifier prior to the quantization step. This quip modifier basically adds transform layers into the model. Some of those layers are fused and some of them remain left over as online transforms. And then those transforms are going to make the subsequent quantization steps much better accuracy recovery. So if you can go to the next slide here, you know, our modifiers both are the quip modifier, which is the kind of scheme that Brian talked about earlier, and then the spin quant modifier, which is the more complex one where we kind of apply different rotations to different modules within the model, and they have them cancel out in a specific way. So both of these modifiers are available in LLM Compressor and are available to use. We plan on extending them a little bit further, like adding support for things like rotations on attention layers to enable better attention quantization. But this is landed right now, and we're very excited for people to start using it. I'll talk a little bit more about that later. Cool. So yeah, for this next segment, we kind of want to talk about where transform support is right now in LLM Compressor and vLLM, and then talk about where we kind of want to go from here, as well as call out some of the other updates and features that have been added to LLM Compressor in our latest release. So in terms of transforms, you know, we've locked down a lot of kind of the engineering that we wanted to do here. This is things like solidifying a transform config that shows up in the config.json file. Things like implementation of the merge rotations and online rotations, and then also like proper serialization of these rotations in a way that maximizes the shared tensors between online transforms. So a lot of the core implementation is locked down right now at this point. We're still adding a lot of support. So things like accelerated kernels for running these transforms in a very fast way in vLLM. As kind of Brian mentioned before, these transforms are Hadamard matrices, and there are specific properties about the Hadamard matrices, such as the fact that it's like -1 and +1, and then also the fact that, you know, a lot of these Hadamard matrices have this recursive structure that's defined within the weight. And these are all aspects that we're able to exploit to get much faster computation of those Hadamard matrices to the point where it's basically no cost in terms of latency and throughput. But those kinds of kernels are the things that we're still working on adding support for, and, you know, we'd love to get more experimentation with. Other things like adding support for transformed attention and KV cache quantization are also on the docket. And then, you know, really what we're kind of looking for in this like next couple of weeks, and then also like in terms of community contributions as well, are things like, you know, model evaluations and guides in how to use these transforms. You know, we've seen a lot of like really powerful accuracy recovery metrics out of these transforms, but we've also seen cases where like these models, you know, might not do as well or even worse with these transforms. So really the next couple of weeks for us is kind of figuring out exactly what are those use cases where it performs the best and where it might not be as helpful. And that's where we'd love to see a lot more community contribution. You know, using spin quant on your favorite model architecture, whether it's a regular model or like an MOE, adding support for those kinds of mappings in LLM Compressor, all of those things are things that we'd love to get more feedback on so we can make this feature the best it can be. And then also, yeah, I'll call out the last thing there is just, you know, learning these rotations. You know, we're seeing more and more over time that a lot of these transforms, they benefit the most when we actually learn these. So either through like a gradient descent or like a constrained gradient descent, or other kind of techniques like reducing the Hadamard size in order to, you know, reduce weight movement into the GPU. And then also, yeah, it seems to be that these are just kind of the better use cases in some of the latest papers, like FTP quant and flat quant as well. Cool. Cool. So that's kind of like transforms in LLM Compressor. I hope you guys get a chance to use them. I'll call out some other things that have landed in the latest LLM Compressor release. So things like support for NVFP4 and MOE. We have new kernels for those as well. We've been pushing really hard for adding better support for like mixed precision models. So right now, our general use case is you take a model, you quantize all of the layers into FP8 or whatever kind of quantization scheme you want. But things like adding mixed precision, we've seen like huge improvement. If you hit the next slide there, we've seen huge improvements from really specific targeting of quantization for different layers, right? So, in this scheme, for example, we target NVFP4 quantization for most layers, and then, leaving the downproj layer within like a llama architecture, for example, leaving that layer as like FP8. And, simple things like that, where we see that some layers are much easier to quantize than others, that can enable us to quantize these models to much lower bit precisions, increasing throughput and decreasing latency, while still maintaining the same exact accuracy for these really extreme bit quantizations. So really powerful techniques here as well, and this is something that we definitely want to work on moving forward. Last thing to call out is just, docs and user guides. This is one of our pushes for the next couple of weeks. Also a place where we'd love to get more feedback in terms of how we can make, the model optimization ecosystem within vLLM the best and as usable as it can be. Cool. Yeah, so extending out just, one layer outwards. We talked about transforms. We talked about some of the latest features like NVFP4. As a general roadmap within the optimization team within Red Hat, and then also, model optimization in general within the vLLM ecosystem, these are kind of our big priorities that we want to see in the next couple months or so. Number one is probably support for transforms. This is things like taking our base implementation and extending it further. So adding things like learned rotations, smaller rotations, things like kernel acceleration for some of these Hadamards. That's a big opportunity there as well. And then also, in terms of community engagement, much more usage like benchmarking across different model architectures, different situations, and then different evals as well. Outside of transforms, I kind of mentioned this as well. Quantization of the KV cache and attention quantization. This is also a really big opportunity as well. We also think that, attention quantization is enabled by some of these transforms that we're seeing, especially on like the R3 rotation within SpinQuant. There's really great opportunities to be quantizing those operations, maximizing throughput, and still maintaining the same exact accuracy that you would expect out of the dense model. Mentioned also before, non-uniform quantization recipes. One of our big tools that we want to push in the next couple months or so is a tool to allow you to accurately assess your model. So be able to like kind of investigate the weights within that model and then see, which weights do we think are the most sensitive to quantization and which ones do we think you can quantize easily to low bit without as much consequence on accuracy. So that's one of our also like big pushes as well. Finally, kind of priority number 4 for us is expanded support for larger models. So this is models on like the 1 trillion parameter sizes. So like Kimi K2, or even some of these like really, really large models like Llama 4s. These models are getting to the point where, we've relied on CPU offloading for a lot of our jobs. But it's getting to the point where these models are so large that we're starting to resort to having things like disk offloading. So features like disk offloading support in LLM Compressor, and then multi-GPU quantization. So being able to accelerate these quantization jobs with parallel execution across multiple GPUs is another place we're looking at as well. Finally, MVFP4 support, both in terms of being able to quantize your models using the LLM Compressor, and then also, kernel support as well, which hasn't been as great as NVFP4 so far, but like still definitely a place where a lot of folks are really interested and a place we see expanding in the future. Sweet. So a lot of information there. Our big recap is this. we now have transforms available in LLM Compressor. You can run these on the latest release of LLM Compressor, and then also, if they have any online rotations that you need, that is runnable in vLLM using vLLM main as of yesterday. Other things, we've added more support for NVFP4, things like block quantization, so being able to quantize your models in like a block strategy in the same way that these DeepSeek models are being quantized. And then also better support for like mixed precision quantization. So some huge opportunities there. In the future, we hope to emphasize things like transforms, mixed precision, and then also enabling these like really large models to be quantized in a fast and non-resource intensive way. So at this point, that's kind of our update. We wanted to open the floor if anyone has any questions about things. Really our goal here is not only to provide you a sense of like what features are available today, but also to kind of get some feedback in terms of, how can we make the model optimization ecosystem around vLLM as strong as it can be. So we'd love to hear things like, what kind of optimization techniques are you most excited about? Things like different quantization schemes, things like different algorithms for quantizing models, kind of use cases, and then also, where can we improve in the ecosystem? So if anyone has any questions, we'll give some time for that as well. I'm sure Michael also, has a slide here to talk about, some of the feedback on vLLM in general as well. So I'll hand off there.
Yeah, thanks a lot, Kyle and Brian. That was, very comprehensive and heavy update. There's a lot of things going on in LLM Compressor. I haven't been following the development, like the recent development too closely. What would you say are some like recent features that have been added by the community, if you're looking for more contribution?
Yeah, things like MOE support is like a huge opportunity there. We've had community members contributing, different modeling, like different changes to model definitions in order to better support MOEs. So things like GPT OSS, for example, are one of these examples where like the model definitions supported by Hugging Face aren't necessarily the best model definitions for actually quantizing these models. So that's a great opportunity to support there as well. A lot of things like MOE architectures that not everyone has the time to get around to, but if you're interested in, that's a great opportunity to support quantization in that realm. Other things, like just usage and validation. If you see a model and you quantize it and you do an eval on it and you post those results, that's really great feedback for us because it shows us opportunities for improvement, and then also places where quantization is working really, really well.
Yeah, great. Those definitely sound like useful features. Are there questions? The slides should be pinned, but I should be able to send it just here. Yeah, there are the slides. Any questions or people that want to speak up and come off mute too? Has anyone used LLM Compressor recently? I've been definitely seeing a lot more, I think, FP4 models than we've even been pushing out ourselves recently. It seems they're pretty popular on Hugging Face, from what I can tell. People always want the lowest quantization format possible, and we just work really hard to make it possible.
Yeah, for sure. I mean, there's been huge interest also for like MXFP4 as well. But the important thing to mention there is, when you do these like very low bit quantizations, it's really important that you use like the best algorithms to support the accuracy recovery there as well.
Yeah, for sure. I'm still waiting from AMD to upstream some MXFP4 kernels into vLLM to make it a a bigger carrot to properly support it. But yeah, currently we have a bit of a kernel problem with it. Right now, really just have Triton kernels and CUDA weight only kernels for it.
Yeah, I know Roberto as well has been talking about trying to push for better MXFP4 like attention kernels as well. Yeah.
Yeah, that's yeah. We need to make FP8 attention more performant before we get there. There's a question from Dong. How does LLM Compressor differ from Torch.io? That's a pretty good question. Torch.io is kind of like a lot of things, in my opinion. It like bundles together a lot of like runtime algorithms and like compression algorithms. And it kind of focuses more on like running models natively in PyTorch versus like producing model checkpoints that are accurate like ahead of time and that are small on disk, which is more where we're focused, where we're talking about like compressing a model once and then deploying it at scale, which is how vLLM is generally used. So Torch.io is more of kind of like an online quantization in place and have kernels attached with, whereas LLM Compressor is like not trying to run the model efficiently, but trying to produce a really accurate compressed model that can be run efficiently by a framework like vLLM with its own kernels and choices on how it's going to run it. So yeah, I think that's the main difference. Like LLM Compressor is really focused on accurate, state-of-the-art compression.
Yeah, I think that's a great kind of great summary. You know, the LLM Compressor, it's really a tool for being able to compress your models in a way that you can actually deploy them in production and know for a fact that they're going to have the same accuracy or behavior as the dense models.
Yeah, we definitely run a lot of evals to validate those. Okay, a question from Adit on the performance between Cutlass and Triton kernels. Yeah, I mean, it varies pretty greatly. I would say it doesn't matter much when you're on like consumer GPUs. But once you get on data center GPUs, once you get on H100s, H200s, B200s, it's just, yeah, you're leaving like half of the performance on the table. Now, Cutlass is not something you use for making like your RMS norm or your layer norm or various things faster. It's really, you know, designed for matrix multiplication. And it's pretty heavy to compile as well. So we are looking forward to some of the like the Qt DSL, the sort of like Pythonic Cutlass that is coming out. That's much more like Triton, but allows for that level of performance that Cutlass offers, but doesn't require C++ metaprogramming. But yeah, I mean, we still use Triton a ton in vLLM. It's just like kind of order of effort, right? Like generally in vLLM, we'll write things using PyTorch until, and then we use Torch compile, and that usually does most things. And then sometimes, okay, Torch compile doesn't auto-generate enough, then we write a custom Triton kernel. And then, oh, okay, this is like a really heavy use case, a really critical bottleneck, like let's write it in Cutlass, or it's an obvious matrix multiplication. So yeah, it's really kind of level of effort that you go to the harder stuff. Yeah. Good question. Yeah, any other questions? People want to speak up? Well, if not, we can call it basically at the top of the hour here. Thanks everyone for coming to office hours today and hearing the update on both vLLM and LLM Compressor. Thanks for keeping up with the project and hopefully contributing.
Looks like Bowen had a question.
Oh yeah.
That's me. It's touched. Sorry.
Yeah. I thought I saw it go back. Yeah. Thanks for being a part of vLLM, and hope to see you at the next office hours and some meetups, hopefully, right? Come out. Okay.